Right, foundation level has got to be looked at before you can start looking at these higher videos. There's some things I'm going to do now that obviously requires prior knowledge of your foundation level skills. So let's begin. I'm jumping into page 57. These are drawing straight line graphs. In other words, you have an equation. You substitute some x values into the equation, work out the y, get the coordinates, plot them, you get a lovely straight line. If you don't get a straight line, you've made a mistake somewhere, so then you need to backtrack. So that's my little hint to you. We go straight into question 5 on page 57. It says, draw the graph of y equals 2x plus 1 for values of x from -3 up to 3. So these are the x values. In other words, that's how wide the x is going to go. So here I go, just like I taught you in Key Stage 3. You write down the x, you write down the y, and then you write down the coordinates. If you remember that, that's really good. So the first x value is -3. Let's substitute -3 into that x value right there. So we've got 2 times -3 plus 1 makes what? So 2 times -3 is -6 plus 1 is -5. So we've created the point -3, -5. Just put that in a little bracket there. In fact, let's just make some separating lines here so we can see what's going on. Should be right. We'll have one there. We'll have one there, and that should be fine. Go across here. Be all right. All right. So that's that. We're now going to do -2. We're going to go from -3 up to 3. So we want two lots of -2, which is -4, plus 1, because it says so. So -4 plus 1 is -3. So we've created the point -2 for the x and -3 for the y part of the coordinate. Now you go -1. Two lots of -1 plus 1. Well, that's going to be -2 plus 1 is -1. Gives us -1 and -1. All right. Now we start with 0. Well, two lots of nothing plus 1 is 1, so it creates the point 0, 1. Start substituting the 1 in. Two lots of 1 plus 1 makes 3. I've got the point 1, 3. Make the x value 2 now. I've got two lots of 2 plus 1. Well, that's 4 plus 1 is 5. And I'm sure you can see a trend if you look at it carefully. Again, we'll study that in a minute. And last of all, two lots of 3. The x value is 6 plus 1 makes 7. We have the point 3, 7. Now look, it's a line. The relationship is linear. Look what's happening. -3, -2, -1, 0, 1, 2, 3. So we're going up in ones for the x. Look what's happening to the y's. -5, -3, -1, 1, 3, 5, 7. It's going up in twos. Not surprising that there's a 2x sitting there. It could be related, I don't know. But anyway, we can then plot those points a little later on to get a lovely line, and that line will be called y equals 2x plus 1. Then says on the same axes, draw the graph of y equals, let's stick it down here. I've got y equals 1 minus 3x, and it's for the same range of values from -3 up to 3. And so I'm going to do another little table. Get one of these little lines. Oops, not that one. That one. Get one of these little lines. I hope I'll make it fit there. So grid like that. Answers and coordinates along the side there. So here we go. So the x values coming up. The equation is y equals 1 take away 3x. Watch out, it's more challenging. Just watch these steps. Try -3 first. So I've got 1 take away 3 lots of -3. Be careful. 1 minus 3 times -3 means plus 9, because minus times a minus is a plus. So 1 plus 9 is 10. I've created the coordinates -3, 10. Alright? So coordinate there, good enough. Now -2. 1 take away 3 lots of -2. Notice the 3 is not going to change because it's 3x. We're just changing the x value each time. So -3 times -2 is +6. 1 plus 6 is 7. I've got the point -2, 7. Again, you'll be able to spot the trends. -1. 1 take away 3 lots of -1. That would be 1 plus 4. Sorry, 1 plus 3 makes 4. I've got -1 and the y coordinate 4. 0. I've got 1 take away 3 lots of nothing. Well, any lots of nothing is nothing, so I'm just left with 1. Got the point 0, 1. As you can see, we're going down in 3's each time. There are 3 x's. How's that? So 1, So 1 take away 3 lots of 1 means 1 take away 3, because 3 times 1 is 3. That gives us minus 2. So it's 1 minus 2. And look, 1 take away 3 takes it down to minus 2. I know we're right, so you can always check it like that. 1 minus 3 lots of 2, well 3 lots of 2 is 6. 1 take away 6 is going to be minus 5. That gives us 2 bracket minus 5. And look, minus 2, take away another 3 is minus 5. So I'm very confident we got it right. Right, last one. 1 minus 3 lots of 3. Well, 3 lots of 3 is 9. But it's negative, so 1 take away 9 is going to be minus 8. And yes, we've gone down another 3. So I can now go and plot these on the other side. Could take me a little while though, because it says B on the same axis. Draw the graph of that one. Yep. And write down the coordinates of the point where the two lines cross. Well, I've got to plot these points, haven't I? Now I'm going to cheat a little bit. Since I've got all these coordinates correct, I'm probably going to plot just the first point and the last point. And as you know, that's the minimum requirement to get a straight line. So I'm going to plot minus 3 minus 5. Right, minus 3 minus 5 is exactly there. So there you go. And the next one is 3, 7. So that's that one. 3, 7. Now incidentally, just to make a point of this, note the x-axis goes up in, you know, 2 little squares at a time, whereas the y-axis, in order to make it fit, I've gone up 2 squares to be worth 2 units. You're allowed to do that. Look, this one's going up in 2s that way and going down in 2s that way. That's consistent. Whereas the x-axis is independent. I can make any scale I want to, whatever's appropriate. So that's just gone up in 1s each time, but taking 2 squares for each unit. So that's allowed, so don't be worried by that. Now let me just join up that line in blue. Now, hopefully this will work. No, I want it in blue. Right, that's better. It was a bit thick. Don't you ever do this in class all thick like that? Won't have it. Right, let's go back. Now I want to plot points for this graph here. Y equals 1 minus 3x. I want to plot minus 3, 10. I do hope that fits. Minus 3, 10, 2, 4, 6, 8, 10. Yes, it's there. And the other one's going to be 3 minus 8. So let's plot 3 minus 8. 3 minus 8. 3 along, 8 down. There. Choose a different flavour to do this. Alright, a bit thick that one, never mind. Bam. Drag it across and let go. Alright, here we go. Let's see what the question says. It says to me, 5c, write down the coordinates of the point where the two lines cross. Okay, so that's right there. Now hopefully if I've done it accurately, then we're going to get away with it. That is the point of intersection. That is the point 0, comma 1. I don't know if you can see that. 0, 1, nothing along, 1 up. If I've drawn it perfectly, I think that's where it should be really. Now let me label my lines. I like leaving things unlabeled. We've got y equals 2x plus 1. That's that one. Y equals 2x plus 1. And the other one was y equals 1 minus 3x. And y equals 1 take away 3x. And I'm happy with that actually. So there's the point of intersection. We've drawn two lines, one with a positive slope or gradient and one with a negative slope or gradient. But that's another topic actually. Let's see if we need to move on to anything else. What I'm going to do is pause the video there. You need to go back and look at how I did that. You need to go forward to see how I plotted it. And I'm sure that if I plotted all the points, they'll be exactly on the blue line for that equation, exactly on the red line for that equation. But in order to save time, I'm just going to plot 2 of each, and I get the appropriate line segments. Certainly, I can see a very clear point of intersection, so let me just label it as such. And I'm happy with it. It's where the two lines cut section. Alright, so thank you for watching. Please study this carefully. We'll see you quite soon.